Okay, so the determination of liquid limit. Okay, so while performing the liquid limit practical, so you know that what is meant by the liquid limit. So what is the liquid limit? As by the phase diagram we know that the liquid limit is the minimum water content at which the soil which change from plastic stage to the liquid stage. Okay, so what are the various apparatus that we required while performing the practical? So these are the various apparatus that we required while performing the so first one, that is this apparatus which is called as a liquid limit device, which is called as a Cassagrade apparatus. So this Cassagrade apparatus which consists of, so this which consists of this is called as a cup, this is a cup, then this is a handle. So handle, if we are manually operated, it is a handle. Okay. Or sometimes here is a electrical motor will be provided over there if manual operation is not there. Okay, by rotating this handle, this cup will shifted up and down. Okay, so then this is called as a spatula. These are the containers, that are used to measure the water content, then this is a soil sample. So here we are using the soil sample which is passing from 425 micron ISU. So here one more apparatus that is used, that is ISU 425 micron ISU generally used. And this red color apparatus which is called as a grooving tool, it is used to cut the sample, so it is having shape like that. Okay, this is a grooving tool. So there are two types of grooving tools we can use. First one, that is called as the ASTM grooves. ASTM, American Society of Testing of Material, that is called as the ASTM grooving tool. And second one, that is called as a Cassagrade grooving tool. So this is a Cassagrade grooving tool. And and the shape of the ASTM grooving tool is like that. This is having the shape like a ASTM grooving tool. Okay, and this is the Cassagrade grooving tool. Okay, so all these are the apparatus that are used to perform the practical on the liquid limit determination. Okay. So what is the procedure generally we follows? So we see here. First of all, take about 120 gram to 150 gram of the soil which is passing through 425 micron ISU. Okay, so you can take 120 gram or 150 gram soil which is passing through 425 micron ISU. Okay, then add a little bit amount of water so that to make a paste. The paste, the same like the paste that we are used for making a brush. So or you can use 20% of water, mix it and make a paste. Then this paste is placed onto the cup. So third step is place onto this cup. So this cup, okay, place onto this cup. Okay, then by using grooving tool, so this red color grooving tool, cut the soil sample into two parts, then give the number of blows, by using this machine until this both the cutted portion are closest together. Simultaneously count the number of blows that we required for closing of this cutted portion, that is called as a groove. Okay, so I will explain by this diagram. So first of all, take the soil sample 150 gram, or we can take 120 gram, in between 120 or 150 gram, then add a little bit amount of water, we can say 20% of water, and make a paste, and this paste is filled into this cup. So here we are placing this soil sample into this cup. Then by using this groove, so this red color groove, that is ASTM, or you can use ASTM groove or cache grade groove. So here we are using cache grade groove. By using this cache grade groove, we can cut the sample. So here we are cutting this sample into two parts. Okay, so two parts we are clearly shown into this figure. Okay, then give the number of blows, by this handle, and note that due to number of blows, what will happen, this cup will shifted up and down shifting of this cup, and due to this shifting up or rapidly movement of this cup, what will happen, this soil sample are closest together at the bottom at 30 mm or 12.7 mm, and stop giving the number of blows, giving the number of blows. So here we can clearly shown after giving the number of blows, the soil sample again closes at the bottom at 12.7 mm from we can measure from the top, and from bottom 3.3 mm from the bottom. Okay, then then this soils, take some part of this soil sample and send it to the laboratory for the determination of the water content. Okay, for determination of the water content. So how we can determine the water content? So water content that can be determined by using this these moisture cans, we can call it the moisture cans or the containers. Okay, so here we are taking the some part of the soil sample, and after taking the some part of soil sample, we can find out the water content by using the oven drying method. So how we can find out the water content by oven drying method? So first of all, we know the formula, the water content by oven drying method. So what is the formula for the water content by oven drying method? The formula is W, that is water content, equal to W2 minus W3 upon W3 minus W1. From that we can find out the water content. So what is the mean by W1, what is mean by W2, and what is mean by W3? That we had already discussed in a determination of water content, but here once again I am explaining what is mean by W1, what is mean by W2, and what is mean by W3. So W1 means the weight of the empty can, or we can call it as a empty container. Okay, weight of empty container. Then W2 means the weight of empty container plus we are taking some part of this soil, and so this is the weight of empty container, so we can call as W1. So W2 means weight of container plus some sort of this soil. We are taking this some sort of soil and fill it into this cup, so it is called as a weight of container plus weight soil. Okay, then place this container in oven for 24 hours at a temperature 105 degrees Celsius for 24 hours. After 24 hours, what will happen? All the moisture that is present into this soil sample will show disappearing. Okay, and after 24 hours take again its weights. So it is weight of, so take again this weights, that is called as W3. So this is called as the weight of container plus dry soil, because this soil which contains no amount of water, because all the waters are removed by using this oven, because oven will give some heat. Due to application of heat, all the water will disappear. Okay, so W1 means the weight of empty container, W2 means weight of container plus wet soil, W3 means weight of container plus dry soil. From that we can find out the water contents. Okay, so now how we give the liquid limit exact. So what is the definition of the liquid limit? Is the water content at which soil is in a liquid stage. For that purpose our test is over at when the groove are closest 12.7 mm at the bottom. At that time we are stopping the giving the number of blows. Okay, and we collect the sample and send it to the laboratory for the determination of water content. So this test is performed number of times, say 2 times or 3 times. So finally we plotting the graph of water content, which is on x axis, and the number of blows on y axis. Okay, so what is the liquid limit? Liquid limit means, so these are some points. So suppose these are some points. Okay, and so this is our curve, so this curve is called as a flow curve. Okay, flow curve, this curve is called as a flow curve. And and what is meant by the liquid limit? Liquid limit means the water content at 25 number of blows. When the so here is number of blows. So 1 number of blow, 2 number of blows. So these are the number of blows,